So good morning, students. Are you able to see the screen and am I audible?
Yes, sir.
Okay, fine. In the last class, I had explained till the spherical coordinate system. The spherical coordinate system, we have three surfaces. One surface is a sphere of radius r, which is at the center of the origin, and second surface is the right circular cone with its apex at the origin. Third, and along the z-axis. Then the third surface is the half plane, which is at an angle phi with respect to the xz plane, at an angle phi with respect to the xz plane. These are the three surfaces which make the spherical coordinate system. Later, we dealt with the intersection of the two planes and the intersection of the three planes. Whenever there is an intersection of theta equal to constant and r equal to constant surface, that will cause a circle, that will result into a circle here, a circular surface. Then when there is an intersection of all the three, this intersection of phi is equal to constant, r equal to constant, and theta equal to constant, when there is an intersection of all the three planes, then that will result into a point P that we discussed in the last class. Okay. In continuation with that, next is the base vectors or the unit vectors. There are three unit vectors in the spherical coordinate system, which is for the coordinates r, theta, and phi directions. And these three unit vectors are AR bar, A theta bar, and A phi bar. AR bar, A theta bar, and A phi bar. These unit vectors are mutually perpendicular to each other. These three unit vectors are mutually perpendicular to each other. We can see in this figure. This is our point P. This is our point P. And this point P has the radius, so it is directed radially outwards. The radius R, the unit vector is AR bar, which is directed radially outward from the origin. Then the angle A theta bar, it is perpendicular to the surface, spherical surface A theta bar. Okay, and it is directed in the direction of increasing angle of theta. This is our half angle theta for the right circular cone. Okay, you can see in this figure the half angle theta for the right circular cone. This one here, half angle theta. Now this is in the increasing direction of the half angle theta, increasing direction of the angle theta. That is our A theta bar, the unit vector A theta bar, and A phi bar is the tangent to the spherical surface. It is a tangent to the spherical surface, and it is also directed in the direction of increasing angle of phi. This is our phi here, so it is also directed in the direction of increasing angle of the phi. Okay, these three are the three unit vectors. One is AR bar, A theta bar, and A phi bar. And we know that always the three unit vectors, whether it may be in Cartesian or in cylindrical or in spherical system, they are mutually perpendicular to each other. They are at right angles to with respect to each other. Okay. Therefore, we have the three unit vectors mutually perpendicular. Unit vector AR bar is directed from center to that is origin to the point P. It is radially outward. Then unit vector A theta bar is the direction of increasing angle theta. Third vector A phi bar is tangent to the sphere. It is oriented in the direction of increasing angle phi. If we obtain the coordinates, if we know the coordinates, then we can write the vector or the unit vector or the base vector that is given by P vector is equal to, which are the coordinates now? Coordinates are r, theta, and phi. And hence we can write the P vector as PR AR bar plus P theta A theta bar plus P phi A phi bar. This is our unit vector. Now, what is the meaning of unit vector, students? Can anybody tell me what is the meaning of unit vector? What is meant by unit vector? Unit vector means if we take the,
Magnitude equals 1.
yes,
Sir,
exactly,
vector by its magnitude, sir.
correct, exactly, good. The magnitude of this vector will be 1. If we take the magnitude of this vector, that is square root of PR square plus P theta square plus P phi square, that will be equal to 1. And hence that is the meaning of the unit vector. PR is the radius here. P theta and P phi are the angle components of the that is angle components of the unit vector in the spherical coordinate system. Okay. Next, differential elements in spherical coordinate system. We have come across differential elements in the Cartesian system and in the cylindrical system. That is, when the coordinates are increased by the differential amount, then how the shape is obtained, what is the shape that is obtained, and how the coordinates are going to affect the system. Okay, that we have seen for the Cartesian and for the cylindrical system. Now we'll go through the differential elements in the spherical coordinate system. Consider a point P of r comma theta comma phi in spherical system. Originally where it was here, the point P you can see in this figure, it is here. Okay, this is our original point. Okay, now we are increasing r by r plus dr. The radius r we are increasing by a differential amount r plus dr. Then theta we are increasing by theta with theta plus d theta. Original value is theta. This is increased from theta to theta plus d theta. Then original value is phi. From phi we are increasing from phi to phi plus d phi. Okay, these are the differential amounts with which we are increasing the coordinates of the spherical system from r to r plus dr, theta to theta plus d theta, and phi to phi plus d phi. Now what is r and r plus dr? They are two spheres. One sphere is having the radius r, another one is having the radius r plus dr. Then the two angles theta plus d theta means there are two cones, right circular cones. One right circular cone is having the half angle theta, another has the angle theta plus d theta. Then there are two planes, half planes. One half plane is making an angle phi with the xz plane, another one is making an angle phi plus d phi with respect to the xz plane. When we consider all these planes, that is two spherical planes, two conical planes, and two half planes, right, this forms a surface. This forms an area, enclosed surface. What is the enclosed surface or the enclosed volume formed by these surfaces? There are 6 surfaces. It is here. This is how the surface is formed. Okay, when all these 6 surfaces put together, they form an enclosed volume or the enclosed surface, and this is how it is formed. Okay, now in this figure we have to find the differential lengths of the r, then theta and phi. Differential lengths as we found out for the previous one for the cylindrical system. When we consider the r, the differential length in r is very simple. It is dr only. Okay, r is increased from r plus dr. The radius r is increased from r plus dr. Okay, r plus dr. Right. Hence, the differential length that is increased for the, that is the radius r, is just dr. Now, what about for the theta? Try to understand here. For the theta, there is a point. One line is joining from O to this point. Can you see here? From O to this point of this surface, the lower point. Okay. Another line is joining from O to P. O to P. One line is joining from O to P. Another line is joining from the O to the bottom point, that is O to this point of the surface. Okay. Now, when these lines are joined here, right, the in between angle between O to P and O to this line, the next lower line, okay, that angle is d theta. It is the small incremental angle d theta. Then what is the angle theta, students? Angle theta is the angle formed between O to P and this z axis. Correct? We know here, just we can see here for the half angle theta. Just now I told there. Here it is, half angle theta. So it is, this angle is theta. That is formed between O to P. Here in our figure, what we are explaining is between O to P. This is our point P, and this is the z axis. That is the angle theta. If this is the angle theta and d theta, then what will be the differential length for the theta? Differential length, here it is O to P and O to this line here, lower line. I am joining, forming two lines here. One line is from O to P, another line is from O to this bottom point of this surface. Okay, the in between angle, that is between O to P and between the O to the next line, that is the angle d theta. Okay, angle d theta. So this this curved length, it is r into d theta, r into d theta, or into sine d theta actually, but the angle sine theta or sine d theta here is very less, so it can be considered as equal to r into d theta, r into d theta. Okay, so this is how we are getting r into d theta as the differential length for the angle theta, or for the angle d theta. Okay, next, so this we found out for the d theta or for the angle theta. Next, for angle phi, angle phi, look here, this is our angle d phi. Okay, what is our angle d phi, students? This is from here to here, it is phi. From here to here, it is phi plus d phi. Now what is d phi? Can you just visualize here? It is d phi, this one in between. From this to this it is phi. From this to this it is phi plus d phi. Phi plus d phi minus phi, that gives d phi. So this angle is d phi. This angle is d phi. I hope you are following here, students. Yes, you are following here, students.
Yes, sir.
Okay, fine,
Yes, sir.
fine. Okay. Now from here to here it is phi. Then this to this it is phi plus d phi. If I take the difference between these two, phi plus d phi minus phi, then that will give me d phi. That will give me d phi. Correct. Now if this is d phi, then if I want to find this arc length, this dashed line, what you are seeing here, okay, this one, what I'm highlighting here with my pointer. Okay, so this dashed line, this is the arc length that we should find out. Now if we want to find out this arc length, it is the product of the radius and the angle that is subtended. Angle that is subtended. Angle subtended is d phi. Okay, radius is r, so it is r sine d phi. Again, sine d phi is very less, hence we can consider that sine d phi as just d phi only. Therefore the arc length that is formed here is r into d phi, r into d phi. Once again I will explain. This is the radius r, this is the radius r, what I am showing here, from O to this radius r. Then the angle subtended here, it is the difference between phi plus d phi and phi, that is d phi. This is the angle subtended. Next is r multiplied by sine d phi. R multiplied by sine d phi is r d phi only, because sine d phi, if angle is very less, suppose angle of sine 1 if you take, or sine phi, or sine 0, right, like that, if the magnitude is very less, then the sign of that angle will be nearer to the value. Okay, so like that, hence sine d phi is nothing but, it is equal to, almost approximately equal to d phi only. Hence I will consider this r sine d phi as r d phi. This arc length will be r d phi, this dashed line, it is r into d phi. Okay, now if this is r into d phi, then this angle here, how much it is increased here when I go from this original point P. We are seeing the original point P here. This is our original point. Okay, when we have not increased the differential amount, when we have not increased with the differential amount, this is our original point P. Now when we are increasing from this point P to somewhere other point, differential point somewhere else, now this is our point P, which is somewhere else, when we are increasing by r to r plus dr, theta to theta plus d theta, and phi to phi plus d phi. That means here this arc length is r d phi, this arc length is r d phi. When I increase this r d phi to some other point P, then it is making an angle theta here. Between O to P, the angle is theta. Between O to P, the angle is theta. Just now I showed here this angle theta. Here it is. For the cone, half angle. Here, half angle theta. Okay, between O to, this is our point O, and this is our point P in our figure, what we are explaining here. And the angle subtended is theta. Therefore, if we consider the r d phi, whatever is formed the arc length, that is increased by how much? This is r d phi. This is r d phi. Okay, this dashed line. The same will be here also, but is increased by how much amount? That is given by the product of this r d phi, whatever is formed here, that multiplied by r d phi multiplied by the sine which is subtended, angle which is subtended, that is sine theta. Okay, so this is r d phi. This r d phi is increased by how much amount? This r d phi is increased by how much amount? That is given by r sine theta, r sine theta d phi. This is r d phi. So if this is r d phi is multiplied by the angle sine theta, here whatever is formed between O to P and the Z axis, that gives by how much amount it has been increased from this arc length to this arc length. That is r sine theta into d phi. Previously it is just r d phi. This is multiplied by this angle subtended, that is sine theta. Hence it is r d phi into sine theta. R d phi into sine theta. This is the arc length. That means for the angle phi, the differential length is given by r sine theta d phi. R sine theta d phi. This point is clear here, students? How we are getting this? You understood this? How we are getting? Yes, please. Did you all understand, dear students? Yes. How we are getting dr, how we are getting r d theta, and how we are getting r sine theta d phi? Is this clear? Concept is clear here?
Yes, sir.
Yes, sir.
Okay, fine. Good. Once we have found out the differential lengths, then if we want the differential vector length in spherical coordinate system, it is given by dl bar is equal to dr bar er bar, that is I am writing the vector, plus r d theta into a theta bar plus r sine theta d phi into a phi bar. Take it as equation 1. Equation 1. Next, if I want to find the magnitude of this differential vector length, then I have to take the square root. Whenever we are finding the magnitude of any vector, we take the square root, then square the that is coordinates and sum them. Okay, that is dl bar, vector dl bar magnitude, absolute value is given by square root of dr square plus r d theta square plus r sine theta d phi square. Take it as equation 2. Equation number 2. What about the volume, students? Differential volume formed by these three elements. It is just a product of those three, as we have already done for the Cartesian and the cylindrical. That is r dr into r sine theta d phi into r d theta. R into r is r square. Then we have sine theta. Then we have dr d theta d phi. Hence it is r square sine theta dr d theta d phi. R square sine theta into dr into d theta into d phi. That's the product of the three coordinates whatever are formed. Therefore, I am writing the volume dV as r square sine theta dr d theta d phi. Take it as equation 3. Equation 3. Then we'll look into the differential surfaces. Differential surface areas in the three directions are shown in the next figure. The vector representation of these differential surfaces are as follows. These are the differential surface areas. This is our r sine theta d phi. Just now we wrote for the angle d phi, r sine theta d phi. Okay, this is the arc length r d theta. Then if this is for the theta, if this is for the phi, what will be the perpendicular direction magnitude? What we are getting here, it is for the ar bar. It is for the ar bar. That is dsr bar. We will get the vector dsr bar. Okay, radius. Okay, therefore for the radius vector normal to ar bar direction, the magnitude of the area is given by this length into this length into breadth. It is r d theta into r sine theta d phi. That is r square sine theta d theta d phi. R into r is r square sine theta into d theta into d phi. That is what is written here. dsr bar is differential vector surface normal to r direction. It is r square sine theta d theta d phi. Similarly, for the other one, that is ds theta bar. This is r sine theta d phi. This is the dr, that is the radius vector dr. Then the perpendicular will be, this is for phi, this is for r. Then the remaining will be the theta. Therefore, the area of that we'll be getting is for the theta, ds theta bar, as the unit vector is the a theta bar, the perpendicular one, remaining one. Correct. Therefore, the magnitude of this area ds theta bar is product of the length into breadth, that is r sine theta, okay, dr d phi, r sine theta into dr into d phi. That is written here, r sine theta dr d phi. For the ds phi bar, last one, ds phi bar, here we have dr, that is our radius vector. One is the radius, another one will be the r d theta. Okay, r d theta is this. r d theta. Just I will show that once again. So this is our r d theta. Okay, this length here. Okay. This is r d theta. Similarly, it is shown here r d theta. That is a curve here. The remaining one. Then the next one that is formed is for the angle a5 bar, the perpendicular one, the unit vector in the direction a5 bar. Therefore, the area that will be formed is for the ds5 bar. ds5 bar. That area I will write it as the product of r into dr into d theta. That is r d theta into this dr. Just it is r dr d theta. That is ds5 bar. Hence, I am writing ds5 bar as differential vector surface area normal to phi direction. That is r dr into d theta. This is about the differential element surface areas in the spherical coordinate system. Next, we will look into the relationship between Cartesian and spherical systems. I hope points are clear up till here, right? Points are clear up till here. Okay, fine. Next, relationship between Cartesian and spherical system. Consider the point P of the coordinates x comma y comma z in Cartesian, and the same point also represented for the spherical system as r comma theta comma phi. What I am highlighting here, what I'm going to tell you all is, consider a point P with the coordinates x comma y comma z in the Cartesian, and the same point is also representing the spherical coordinates, that is P of r comma theta comma phi. This is our x, this is our y, then this is our z. This I have considered some point in the Cartesian system, and the same point also represents the coordinates of the spherical system, that is r, radius r, angle theta and angle phi, that is r, theta and phi. That I have written it as P of r comma theta comma phi. Okay. Now next we have to find what is sine theta, what is cos theta. If I consider this cos theta, okay, cos theta, right? How much will be cos theta here? Can you tell me? Cos theta. This is our adjacent side. This is our hypotenuse. This is a right, this here it is forming a right angle triangle. This is cos theta. Adjacent side is z. Hypotenuse is r. Okay. Therefore, it is cos theta is equal to z by r. Cos theta is equal to z by r, or z is equal to cos theta is equal to z by r. Z is equal to r cos theta. Correct. That is, I have written cos theta is equal to z by r, or z is equal to r cos theta. Similarly, find the sine theta. Sine theta. What is sine theta, students? Sine theta is opposite side by hypotenuse. Sine theta is equal to opposite side by hypotenuse. Therefore, what will be opposite side? Sine theta is equal to OP opposite side divided by r. This opposite side divided by r. Opposite side will be equal to r sine theta. That is, here I have shown r sine theta. This one. This is r sine theta. That is, sine theta is equal to sine theta. It is opposite side by r, or opposite side is r sine theta. We came to know what is cos theta, when what is sine theta. Next, we have to find this angle phi. Same as we did for the, that is the cylindrical system, when we converted from Cartesian to cylindrical. Yes, there we consider this angle phi. Okay, then I explained that this is forming an angle of 45 degrees because x to y is 90 degree. It is equally bisecting. This is also 45 degree. Then this is 45. This is 45 means this is also 45 because they are alternate angles, and this will be 90 degrees here. This one, what I am showing here, between x to this, and that is this line. It is a 90 degrees. Therefore, here it is also forming a right angle triangle. Right angle triangle. Okay. Now the angle, this cos phi. Cos phi will be how much? It is adjacent side, that is x, divided by the hypotenuse. That is, hypotenuse is this one. It is not r. Note that it is not r. It is r sine theta, because this and this are parallel and equal. Okay. This is r sine theta. R sine theta. Therefore, cos phi will be x divided by r sine theta, or x is equal to r sine theta cos phi. That is, look here, cos phi will be equal to x divided by r sine theta, or x is equal to r into sine theta into cos phi. We got the x. X is r sine theta cos phi. Next, let us find similarly the cos phi. Cos phi. This is what we found out here for x equal to, it is cos phi. Fine. Let us find out for the sin phi. Sin of phi, it is opposite side by hypotenuse. Opposite side is y. Then hypotenuse is r sin theta. It is not r. It is r sin theta. Therefore, sin phi is equal to y divided by r sin theta, or y is equal to r sin theta into sin phi. That is, sin phi is equal to y by r sin theta, or y is equal to r sin theta into sin phi. Y is equal to r sin theta into sin phi. Correct. Therefore, we got x. X is r sin theta cos phi. We got y. Y is r sin theta sin phi, and we got z. Z is equal to r cos theta. Therefore, students, if we want to convert from the spherical system, that is, which is having the coordinates r, theta and phi, r theta and phi, r theta and phi, and r theta here, we have to use the equations x equal to r sin theta cos phi, y equal to r sin theta sin phi, and z is equal to r cos theta. This is conversion from spherical system to Cartesian system. RHS is spherical system, LHS is Cartesian system. X, Y, Z, they are Cartesian. R, theta, and phi, which are on the RHS, R, theta, phi, R, theta, phi, R, theta. They are the spherical coordinates. Correct? Hence, the transformation from spherical to Cartesian can be obtained from the equations x equal to r sin theta cos phi, the same equations, y is equal to r sin theta sin phi, and z is equal to r cos theta. Next, we'll try to find out how to convert from, that is, Cartesian to spherical. Now we found out what is the conversion from or transformation from spherical to Cartesian. Next, let us find out the transformation from Cartesian to spherical. That is, RHS will be Cartesian coordinates and LHS will be spherical coordinates. Let us take the x square of this term, y square of this, and z square of this. Hence, x square plus y square plus z square. What will be x square? R square sin square theta cos square phi. R square sin square theta cos square phi. That is x square plus y square. Y square will be r square sin square theta sin square phi. R square sin square theta sin square phi plus z square. Z square will be r square cos square theta. R square cos square theta. Okay, write them. Then this is further equal to r square. Here sin square theta, r square and r square sin square theta, they are common in first and second term. Take them outside. R square sin square theta into cos square phi plus sin square phi, or sin square phi plus cos square phi. Sin square theta plus cos square theta is 1 according to our geometry. Okay, plus r square into cos square theta, r square into cos square theta. Therefore, here we are getting r square sin square theta into 1 plus r square cos square theta. Again, here we are having r square common, r square sin square theta plus r square cos square theta. That is r square into sin square theta plus cos square theta. Sin square theta plus cos square theta is 1. That is given by, it is equal to simply r square. Therefore, what will be r? We know that x square plus y square plus z square is equal to r square. Hence, r will be equal to square root of x square plus y square plus z square. R will be equal to square root of x square plus y square plus z square. Fine. Next, let us try to find out y by x. This is our y. This is our y. This is our x. If I take y by x, what will get cancelled out here? Can you tell me? What will get cancelled out if I take y by x?
R sin theta cancels, sir.
Exactly. R sin theta in both of them cancels. Hence, we get tan of phi, y by x. Okay, that is equal to tan phi, sin phi by cos phi. Or tan phi is equal to y by x, or phi is equal to tan inverse y by x. Tan phi is equal to y by x, or phi is equal to tan inverse y by x. Then cos theta, we have already written that. That is equal to r cos theta. Therefore, if you want for cos theta, that is just z by r. Z by r. If we know r is known, then theta can be obtained. If we know r, then we'll be able to find out the value of theta. How? Look here, r is given by square root of x square plus y square plus z square. Theta is cos inverse z by r. Theta is cos inverse z by r. That is cos inverse of z divided by r. R is square root of x square plus y square plus z square. Like this, we'll be able to find the r theta and phi. Phi is given by tan inverse y by x. Clear, yes, students? Like this, we are converting from what we converted from the spherical system to Cartesian system. These are the equations. It is x equal to r sin theta cos phi, y is equal to r sin theta sin phi, z equal to r cos theta. Then we converted from what to what? Cartesian to spherical. And the equations we got was r is equal to square root of x square plus y square plus z square. Theta is cos inverse of z divided by square root of x square plus y square plus z square, and phi is equal to tan inverse y by x. Okay. Fine, students. I hope this conversion is clear, transformation is clear here from Cartesian to spherical and spherical to Cartesian. Any doubts here? Yes. Any doubts here, students? This transformation is clear?
Yes, sir.
Okay. Let us solve an example. Please take down this example. Convert point P of 1, 3, 5 from Cartesian to cylindrical and from Cartesian to spherical coordinates. Convert the point P of 1, 3, 5 from Cartesian to cylindrical and spherical coordinates. Note on this statement here, statement of the example. I hope you all noted down, students.
Yes, sir.
Okay. It is very much simple. What is given here? First, we have to know what is given, and then we have to understand what we have to find out. Okay. That is how we solve any example. When any example is given to us to solve, first we write the given data, is it not? Then we go on solving. The given point is P of 1, 3, 5. What it means? X equal to 1, this is in Cartesian, is very much clear. X equal to 1, y equal to 3, z is equal to 5. X comma y comma z. Okay, is in Cartesian because they are all of them are, that is Cartesian coordinates, x, y and z. X equal to 1, y equal to 3 and z equal to 5. If we want to convert from Cartesian to cylindrical, then what are the equations? That I explained in 2 or 3 classes back. Cartesian to cylindrical conversion. Just if you can recollect those equations, well and good. Cartesian to cylindrical conversion. Here it is. Cartesian to cylindrical. R is equal to square root of x square plus y square, and phi is equal to y by x, and z equal to z. Conversion from Cartesian to cylindrical. R is square root of x square plus y square. Phi is tan inverse y by x, or tan phi is equal to y by x, and z equal to z. Let us use these equations in converting from Cartesian to cylindrical. The same equations I am using here. R is equal to square root of x square plus y square. That is, x is known, y is known, square root of 1 square plus 3 square. Try to find out this value, students. R value, square root of 1 square plus 3 square. Tell me how much you are getting. R is equal to square root of x square plus y square. 1 square, square root of 1 square plus 3 square. Tell me how much you get. The value. How much is the value, students? Take your calculus and calculate.
3.162.
Yes, you are right. 3.162. Correct. Next, to find out phi value. Phi is tan inverse y by x. Phi is tan inverse y by x. Tan inverse y is 3 divided by 1. X is 1. Find out the value tan inverse 3 by 1.
Se-
71.56.
71.56.
Very good. 71.56. Fine. Z is same. Z equal to Z only. That is equal to 5. Okay. Therefore, the cylindrical coordinates for the given point P of 1, 3, 5 are P of R is R, 5 and Z. Cylindrical coordinates are R, 5, Z. Is it not? That is 3.1622, 71.56 degree, 5. These are in cylindrical system. Next, we have to convert from Cartesian to spherical. Just now we have discussed the topic of conversion from Cartesian to spherical. That is, our R is square root of x square plus y square plus z square. Theta is cos inverse of z divided by square root of x square plus y square plus z square. And phi is tan inverse y by x. Let us find out now. R is the square root of x square plus y square plus z square. Find out this value. Square root of 1 square plus 3 square plus 5 square. See how much you get. Because x is 1, y is 3 and z is 5. That is square root of 1 square plus 3 square plus 5 square.
5.9161.
Correct. Exactly. 5.916. Next, go for finding the value of, that is theta. Theta value. Theta value, we know that it is cos inverse of z divided by square root of x square plus y square plus z square. Find out the value of theta. We know z, we know x, y and z. Okay. Cos inverse of z divided by square root of x square plus z square, that will give us theta.
Sir, 32.31 degree.
Correct. 32.31 degrees. Fine. Next, find out phi value. Phi is equal to tan inverse y by x. Phi is equal to tan inverse y by x. Find out phi. I hope others are getting the values here. Yes. Other students. Sampath.
71.56.
Correct. 71.56.
71.56.
Exactly. Exactly. Good. I hope others are getting the values here. Any difficulty here in getting the values? Other students. Sampath. Sampath. You are getting here.
Sir, I am outside.
Okay. 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 Just you have to solve that, right? Solve the example and get it done. Sampath.
Yes. Yes.
Okay. Okay. Fine. What about others? Any difficulty here? Others?
No, so getting the values.
All are getting? No problem in this example. Okay. Fine. In today's class, we have dealt with the topics on unit vector or the base vector for the spherical coordinate system. Then we discussed differential elements in spherical coordinate system, how we are getting r d theta, and how we are getting this r d phi, and we are finding this r sine theta into d phi, that is for the angle phi, right? We have written those differential length in r direction as dr, in phi direction as r sine theta d phi, and in theta direction as r d theta. Then differential length, we got it as dr ar bar plus r d theta a theta bar plus r sine theta d phi a phi bar. Differential length vector magnitude is magnitude of dl bar is equal to square root of dr square plus r d theta square plus r sine theta d phi square. Simple. Next one is a volume dv, that is multiplication of all the three coordinates, that is r square sine theta dr d theta d phi. Then later on we explained the differential vector surface areas, that is dsr bar. We got it as the product of r d theta into r sine theta d phi. It is this into this, that is our r square sine theta d theta, that is for the dsr bar, normal to r direction. Then for the normal to theta direction, it is r sine theta into dr into d phi. Then similarly for the normal to phi direction, it is just r dr d theta, r dr d theta. Okay. Then relationship between Cartesian and spherical system, we consider a point P of x comma y comma z. Same point P is also for the spherical system coordinates, that is r comma theta comma phi. We understood how there is a conversion taking place, or how which formulas we have to use to convert from Cartesian to spherical, or which formulas we have to use for converting from spherical to Cartesian. These are the equations: x equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z equal to r cos theta for conversion from spherical to Cartesian. Then for converting from Cartesian to spherical, r is equal to square root of x square plus y square plus z square. Theta is cos inverse of z divided by square root of x square plus y square plus z square, and phi is tan inverse y by x. Later on, we solved an example for converting the given point P from Cartesian to cylindrical, how to convert it using the available equations, and how to convert the given point P from Cartesian to spherical coordinates. Okay. Any difficulty here, students, in today's class? Any difficulty, students?
No, sir.
Suraya Banu, any difficulty? Suraya Banu?
No, sir.
Okay. Shraddha,
Yes, sir.
any difficulty, Shraddha, in today's class?
No, sir. No difficulties.
Good. Adarsh, Shinde,
No, sir. No, sir.
any problem here in today's class, Adarsh? Any problem in understanding? Adarsh?
No problem, sir.
Okay, fine. Sai Prakash? Sai
Yes, sir.
Prakash,
Yes, sir.
any difficulty in today's class? Anything not understood?
No, sir. Understood, sir.
Understood? Good.
Yes, sir.
Okay, fine. Okay, then we'll wind up here. Okay, we'll continue in the next class in next with the next topics. That is our here we are explaining in the next topic about the vector multiplication. This you have studied in your first year level. How to multiply the two given vectors, right? And how to find the scalar dot product, cross product. Okay, all those will just give a say we'll go through them. Right, you have already studied about these vectors in your first year level. Okay, that's dot product, cross product, and other topics. Okay, that we'll take up in the next class. Okay, anything you all want to ask? Yes. Okay, then we'll wind up here. Thank you.